20 years ago, SpaceX was just another startup that industry giants dismissed. Today, they're the undisputed leaders of the space industry, having revolutionized how we think about rockets and space travel. But history has a way of repeating itself, and there's a new player that's about to shake up the space industry once again. Meet Rocket Lab's Neutron, a groundbreaking rocket that's not just challenging the status quo, it's redefining what's possible in space launch technology. With its revolutionary carbon composite construction, innovative clamshell design, and cutting-edge 3D printing methods, this isn't just another rocket. It's a glimpse into the future of space transportation. In 2025, this medium-lift rocket is set to make its debut, and the implications could be massive. From potentially saving NASA billions on Mars missions to offering a more efficient solution for satellite launches, Neutron is positioned to disrupt the industry in ways that even SpaceX might not have anticipated. Welcome to Elon Musk's 24 Hours. Let's dive right in. The story of Neutron begins not in a corporate boardroom, but in the determined minds of engineers who dared to challenge conventional wisdom. While SpaceX dominated headlines with Starship's massive size, Rocket Lab's team was quietly revolutionizing rocket design from the ground up. Their secret weapon? The humble carbon fiber composite, but reimagined in a way that would make even veteran aerospace engineers stop and take notice. In the sprawling facilities of Rocket Lab's manufacturing plant, a technological marvel comes to life. Their custom-built 3D printer, a behemoth of precision engineering, works with an almost hypnotic rhythm, laying down carbon fiber at a blistering pace of 100 meters per minute. But what makes this process truly remarkable isn't just its speed, it's the integration of artificial intelligence that monitors every microscopic detail. As each layer of carbon fiber is laid down, advanced sensors scan for imperfections thousands of times smaller than a human hair. It's this obsessive attention to detail that could make Neutron not just another rocket, but a turning point in space exploration. The real breakthrough, however, came during a late-night engineering session when the team was grappling with the age-old problem of fairing recovery. For decades, rockets had simply discarded these expensive components into the ocean, a wasteful practice that had become an accepted cost of spaceflight. But one engineer asked a simple question: what if the fairing could be more than just a protective shell? This led to the development of Neutron's revolutionary clamshell design, a mechanism so elegant in its simplicity that it seems obvious in hindsight. Like a mechanical flower blooming in the vacuum of space, Neutron's fairing opens to release its payload, then gracefully closes before making its journey back to Earth. The heart of this mechanical marvel is the Archimedes engine, named after the ancient Greek mathematician who understood that simple principles could solve complex problems. But developing this engine was anything but simple. Early prototypes faced numerous challenges, from combustion instability to material failures. The breakthrough came when the team discovered that by using liquid methane and oxygen, they could create an engine that not only performed better, but could be reused more efficiently than traditional designs. The impact of these innovations became crystal clear during a crucial meeting with NASA officials. The space agency was facing a crisis with their Mars sample return mission. Originally budgeted at $10 billion, costs had spiraled out of control, threatening to cancel humanity's first attempt to bring Mars samples back to Earth. The room was tense as Rocket Lab's team presented their alternative, a bold plan using 2 Neutron rockets that could slash the cost to just $2 billion. The proposal was met with initial skepticism. How could a relatively new company promise such dramatic cost savings? But as the team walked through their detailed analysis, the skepticism turned to excitement. Here was a practical solution, what had seemed an insurmountable problem. This cost-effectiveness isn't just theoretical. While SpaceX's Falcon 9 continues to command $67 million per launch, and ULA's Vulcan Centaur asks for up to $200 million, Neutron's innovative design and manufacturing process could rewrite the economics of space access. The savings come not just from the reusable components, but from the entire philosophy of the design. Every gram of weight saved in construction means more payload capacity or less fuel needed. The development timeline reads like a thriller. Throughout 2022, the team raced against time to complete crucial infrastructure and prototype testing. There were setbacks, of course, failed tests, manufacturing challenges, moments when it seemed like the goals were too ambitious. But each failure brought new insights, and the team pressed on. The establishment of the Archimedes test complex at NASA's Stennis Space Center marked a turning point. Here was tangible proof that Rocket Lab was serious about revolutionizing space launch technology. As 2023 dawned, the pace accelerated. Engine ignition tests began, each one bringing new data and refinements. The successful hot fire testing of the first Archimedes development engine in August wasn't just a technical milestone. It was validation of years of innovative thinking and relentless determination. Now, as Rocket Lab enters the final stages of preparation, the space industry watches with intense interest. The team is running flight mechanism tests, finalizing the Stage 1 build, and preparing for comprehensive static fire tests. Each step brings them closer to their target, a first launch in 2025 that could reshape our access to space. Now, as Rocket Lab enters the final stages of preparation, the space industry watches with intense interest. The team is running flight mechanism tests, finalizing the Stage 1 build, and preparing for comprehensive static fire tests. Each step brings them closer to their target, a first launch in 2025 that could reshape our access to space. Meanwhile, the competition isn't standing still. SpaceX continues to push the boundaries with Starship, their next launch planned for January 11th, 2025. The successful static fire test of Booster 14, with all 33 Raptor engines roaring to life on December 9th, 2024, showed that the race for space supremacy is far from over. Their upcoming flight will feature Ship 33, the first Block 2 Starship upper stage, representing another leap forward in rocket technology. But perhaps the most fascinating aspect of this story is what it reveals about innovation itself. In an industry dominated by billion-dollar budgets and massive corporations, Rocket Lab has proven that clever engineering and fresh thinking can sometimes accomplish what brute force and unlimited resources cannot. Their approach to Neutron's design challenges the fundamental assumptions about how rockets should be built and operated. The implications extend far beyond just launching satellites or sending supplies to space stations. As humanity stands on the brink of becoming a multiplanetary species, the need for reliable, cost-effective access to space has never been greater. Neutron represents more than just another rocket. It's a testament to human ingenuity and the power of questioning established norms. The success of Neutron could open new possibilities for space exploration, scientific research, and commercial space activities. Imagine a future where launching satellites is as routine as sending cargo by air, where Mars missions don't require decade-long budget negotiations, and where the dreams of space entrepreneurs aren't limited by launch costs. As we watch Neutron's development unfold, one thing becomes increasingly clear. The space industry is no longer just about who has the biggest rockets or the deepest pockets. It's about who can innovate most effectively, who can find elegant solutions to complex problems, and who can make space access not just possible, but practical. Rocket Lab's journey with Neutron reminds us that sometimes the biggest revolutions come not from giant leaps, but from smart, thoughtful steps in the right direction. As we look toward the future of space exploration, one thing becomes crystal clear. The next chapter isn't just about bigger rockets or deeper pockets. It's about smarter solutions, more efficient designs, and the courage to challenge conventional wisdom. Rocket Lab's Neutron represents exactly this kind of innovative thinking, proving that sometimes the most revolutionary changes come from asking different questions rather than following established paths. While SpaceX continues to push boundaries with Starship and traditional aerospace giants maintain their course, Rocket Lab's approach with Neutron reminds us that there's always room for innovation in the space industry. Their carbon composite construction, revolutionary clamshell design, and ambitious cost reduction goals aren't just technical achievements. They're signposts pointing toward a future where space access becomes truly routine and affordable. The space race of tomorrow isn't just about reaching new destinations. It's about making those journeys sustainable, efficient, and economically viable. As Neutron prepares for its 2025 debut, we might be witnessing not just the launch of a new rocket, but the dawn of a new era in space transportation. If you're as excited as we are about the future of space exploration, make sure to hit that subscribe button to stay updated with all the latest developments on Elon Musk 24 hours. Drop a comment below with your thoughts on Neutron's innovative features, and don't forget to like and share this video with fellow space enthusiasts. Together, let's continue exploring the fascinating world of space technology and innovation. Breaking news. The next Starship launch could be just weeks away, not months as previously expected. While NASA documents had pointed to January 2025, recent developments suggest we might see Flight 7 take off before the end of 2024. The pace of progress at SpaceX has been remarkable, with the Federal Aviation Administration fast-tracking their approval process and the FCC already granting the necessary launch licenses. This is particularly exciting because Flight 7 builds on the successful elements of Flight 6, significantly streamlining the regulatory process. On December 4th, the FCC made a crucial update to SpaceX's launch license, opening a launch window from December 14th, 2024, all the way through June 2025. With SpaceX's hardware preparations moving at an unprecedented pace, including the completion of critical testing on Booster 14 and Ship 33, we could be witnessing history sooner than anyone anticipated. Welcome to Elon Musk 24 Hours, where we bring you the latest developments in space exploration and innovation. Let's dive right in. At the heart of SpaceX's rapid progress lies an untold story of human ingenuity and relentless determination. While the world watches launch dates and test results, a dedicated team of engineers works around the clock at both Boca Chica and McGregor, pushing the boundaries of what's possible in space exploration. The journey of Booster 14 represents one of the most ambitious engineering projects in human history. During October's cryogenic proof testing, engineers held their breath as liquid nitrogen, colder than the harshest winter night, coursed through the booster's veins. The massive structure creaked and groaned under the extreme conditions, but stood firm, a testament to thousands of hours of design refinements and the lessons learned from previous launches. One senior engineer later remarked that the successful test brought tears to his eyes, knowing how far they'd come since the early days of the program. The installation of the 33 Raptor engines on Booster 14 wasn't just another milestone. It was an orchestra of precision engineering. Each engine, a marvel of modern technology, generates thrust equivalent to 10 Formula One cars at full power. The installation process requires surgical precision, with teams working in perfect coordination. A slight misalignment of even a fraction of a millimeter could spell disaster during launch. The integration team developed an innovative new mounting system for Flight 7, incorporating insights from the previous flight's data. This breakthrough alone shaved days off the installation process while improving reliability. Ship 33's journey has been equally remarkable. After its return from McGregor, engineers discovered something unexpected during routine inspections, a minor anomaly that led to a major improvement in the thermal protection system. This discovery prompted a rapid redesign of several key components, making Ship 33 the most resilient Starship upper stage ever built. The 6 Raptor engines installed on Ship 33 incorporate cutting-edge modifications that improve their performance in both atmospheric and vacuum conditions.